In this video, we're going to learn how to do magnetic bearing, how to actually calculate it. And in order to work out magnetic bearing, we know that there are actually two other steps that you need to complete in the sum in order to find the magnetic bearing answer. So if we look at what is the formula for magnetic bearing, we know that it is true bearing plus the magnetic declination angle for the current year or for whatever year they actually ask you to use, and that would then equal the magnetic bearing. But if that, okay, so that's the formula, but now what does it actually mean? What's important to focus on is that when we do bearing, remember we're trying to give an accurate idea of a location from one point to another, and usually with true bearing we use true north as the actual reference to then work out the bearing angle. So the true north would go through where you're going from. So if we were going from point A to point B, we know that where we're going from is where you're putting that north-south line, that starting point. That north-south line has a reference to the true north. So you're using true north as your starting point, and then you're connecting to where you're going to, and you're measuring the angle in between so that you can then give a bearing, a true bearing, using north as that reference, that 0 degree north. Okay, so that is where you try and find true bearing. And obviously in this example, you would maybe sit with, I don't know, let's make it up 110 degrees as the angle. But, and that would be the true bearing angle, all right, from A to B. But the challenge comes in is that our maps are then printed, orientated to this north degree true north. But when we use a compass, it is not going to align its little north arrow, okay, so the little arrow that's on a compass that you all played with in the Bush School experience at school last year, that particular compass is going to point to magnetic north, not true north. Okay, so what magnetic north is we know that there's a magnetic field coming from the Earth's core, and that magnetic field is going to generate a magnetic north, okay, and a magnetic south. And the compass arrow is going to then be attracted and aligned to point to magnetic north, all right, not true north. So our maps are pointing to true north, which is the physical north. If we take the north that is found by the dimensions of the earth and we kind of divide it in half, the physical north is the true north, and then the magnetic north is determined by that magnetic field. And we find in South Africa that magnetic north is always to the west or the left-hand side of true north. Okay, and that then means that we actually create a little angle between the two. There's an angle of difference between the two. And the difference between true north and magnetic north, that angle is known as the magnetic declination angle. And I commonly call it the pizza slice, okay, because it looks like a pizza slice to me. So there's my little pizza slice. And so that is the angle between true north and magnetic north. So the trouble comes in is that when we are trying to locate one place from another, we might say that A is 110 degrees, or B, sorry, is 110 degrees away from A. But if we try and use a navigation system like a plane, or and we try and fly and put in the bearing of 110 degrees, the plane is going to be pointing to a different north than true north. The plane is not going to be pointing, that compass is not going to actually use true north as its starting point. It's going to use magnetic north as its starting point. So it's going to point and say, north is here. That's my starting. And so then it's going to calculate from there 110 degrees, and it will end up stopping at this point here. And so then we have this gap where there is going to be an error. You're not going to find your location B, because that gap accounts for the gap between true north and magnetic north. So what we do is we say the true bearing that you originally calculated, okay, from A to B, and that was 110 degrees, and we plus the size of the pizza slice, this particular angle. So we take the size of that angle, and it will either be given to you or you will need to calculate what it is for the current year. We will look at that as the next example. But you take the size of that angle, so say for instance it was 23 degrees and 5 minutes. Then you plus the two together, and you are then going to say 110 plus 23, because it's degrees plus degrees, and we get 133 degrees 5 minutes. That becomes the magnetic bearing. And so then when we put into our navigation system 133 degrees, we are accounting for the extra angle that is the angle between the true north and the magnetic north, because our compass system, our navigation system, is going to point to magnetic north, not true north. So we add in the extra pizza slice to true bearing and get a magnetic reference, which will then mean that if we are navigating 133 degrees, will then allow us to end up on point B.